Okay guys, now we're going to be talking about moments, which are the turning effect of a force. As we said in the last video, we said that moment is equal to the force multiplied by the distance from the pivot that is perpendicular to the force. This is what can create or calculate the turning effect. Now for any object that is in equilibrium, we can say that the sum of the clockwise is equal to sum of anti-clockwise moment. Basically, as you can see, this is the turning effect in the anti-clockwise and this is the turning effect in the clockwise. If they are equal, the object is stable. Also, if the resultant force is zero, which basically means the sum of the forces going up are equal to the sum of the forces going down. If these forces are equal, then therefore the object is stable. So those are the two main conditions for equilibrium, okay? Let's take a simple case of calculating turning effect. If you got a pivot like this and the distance is 1 meters to the 1 meter to the force, as you can see, the force is going in this direction, right? And the distance is perpendicular on its direction. So if you are pushing from this direction, then this whole object wants to turn in this direction. So this is what you call anti-clockwise motion. How are you gonna calculate it? It's equal to the force multiplied by the distance. So multiply force times distance is how you calculate. It's 100 Newton meters. Okay. If you look at this example now, this force is coming at an angle. So if you want to calculate this force, you can no longer use this distance. Okay. You want to calculate the distance that is perpendicular on this force so you can calculate its turning effect. So at this case, it's going to be acting at the 0.6 meters. So that's how you're going to calculate the moment is 100 times 0.6. So it's going to be 60 Newton meter. In this case, it's like the red car case, basically. This force is going at what exactly 90 degrees, or there is the distance is zero from the pivot, right? So the moment of this force is going to be zero. It's not going to be causing a turning effect. It's just going to be passing in this direction. Okay, so that's the main idea of how to calculate moment. Now let's see different examples. So we said moment is equal to force times distance. So as you could see, the moment increases with force and increases with distance. Okay, so in these cases, you've got A, B, and C, right? So at A, this is, as we said, this is minimum, there's no moment because the distance to the pivot is zero. This is the pivot. So it's exactly passing by. So if it's the same force, now we're using the same force at A and B and C. If you use B at this point, it's gonna cause a turning effect, but it's gonna be smaller than the turning effect caused at C. So C is gonna have the greatest turning effect as it got the greatest distance. So that's the main idea. Using a force with the distance can cause a turning effect, but you gotta choose the distance wisely and gotta choose the force wisely as well. Okay, so if you increase the force and you increase the distance, you directly increase the turning effect. And it depends on the situation, basically. Now let's see this. It's applied in this case. If you see, this distance 2 is here and this is distance 1. Okay, so this small astronaut is actually balancing this heavier astronaut. Why so? Because though he's got a smaller force, but he's got a larger armature, there's a larger distance to the pivot. So therefore, now the turning effect of this small astronaut is balancing with the turning effect with the larger astronaut. Now the larger astronaut got a smaller distance, so therefore it's causing a smaller turning effect. Let's look at this question of a seesaw. Usually they always ask you in this part, so it's either they eliminate the distance and ask for it or eliminate the force and ask for it, and they tell you the object is in equilibrium. Now since the object is in equilibrium, you can apply the two laws we agreed on, which is the resultant force is zero or the resultant moment is zero. So in this case, we know that this one, these tires are applying a force downward, this one is downward, and this one is downward. And you also got one force from the pivot that is upward. So if you take the moment at this point, this is gonna act in this direction, and those two are gonna act in this direction. So 320 times 3 plus 500 times 1 is equal to 3W from the opposite side. Doing that, you get this equation basically 1500. W times 3 is equal to 1500. So at the end, the weight is equal to 500 newtons. Also, the question could be, as I said, eliminate the W, give you, I could give you the W is 500 and eliminate this and say X, and you could do the algebra to get X, basically following the same idea. Okay, thank you for listening.